welcome to StudyBridge. In our last session, we learned that protons define an element. But what happens if the number of neutrons changes while the protons stay the same? That's where isotope comes in. So we can define isotopes as atoms of the same element. Of course, they have the same number of protons, but with different number of neutrons. So like we said in our last lesson, the proton count makes them the same element. The neutron difference makes them slightly different versions of that element. I will explain. Let's picture carbon with three isotopes. When we talked about atom and its components, we talked about the neutron, the proton, and electron. In the case of a carbon isotope, what makes them different is their number of neutrons. Of course, the proton number is like their surname. It gives them that identity of carbon is 6. The electron is 6. And then what separates them is the number of neutrons. For example, this one has 6 neutrons, which is indicated by 6n here. 6 neutrons. This one has 7 neutrons, the carbon 13, which is indicated with 7n. This one has 8 neutrons. Of course, on the downside, this is the proton, which is 6, and then this is 6 protons. So the first one has 6 neutrons, the second one has 7, and the last one has 8. So this is where they are different. The first one, 6 proton and 6 neutron, is carbon 12. The second one, 6 neutron and 6 proton and 6 neutron, is carbon 13. The last one, 6 proton and 8 neutron, is carbon 14. So this is how they got their names. And remember that the more neutron it has, the less stable it is. For example, this one is radioactive. This one is, of course, is less stable. It's less stable than the carbon 12, which is very stable. So they look alike in the chemistry class, but in physics class they deviate differently. Carbon 14, for example, is radioactive, while the carbon 12 is stable. So the next example you're going to look at is hydrogen. These are the isotopes of hydrogen. The first one, the hydrogen 1, which has 1 proton and 0 neutrons. The second one has 1 proton and 1 neutron here. Then the last one is the hydrogen 3, the tritium, which has 1 proton and 2 neutrons. And of course, is very radioactive. This one is less stable. And this is the most stable version of hydrogen. Of course, they are the same element with the same identity, just with different neutron weights. Because the number of protons is the same, isotopes have the same chemical behavior, but extra neutron changes the mass and sometimes the stability of the nucleus. So it's safe to say that the presence of more neutrons makes the nucleus unstable. So in our next lesson, we're going to be looking at atomic mass. We're going to be looking at atomic mass number, and mass atomic unit. Atomic mass number, and atomic mass units, AMU. So this is what we're going to look at in our next lessons. I can't wait to see you.